My dear students, in the last class we were discussing the relationship between potential difference across the conductor and the current flowing through it. The relation is the potential difference across the conductor is directly proportional to current flowing through the conductor. In simple sense, we can say that more voltage, more current, less voltage, less current. This is the relation between voltage and current. In 1827, a German physicist, George Simon Ohm, found this relation, and hence this relation is named after George Simon Ohm and is called Ohm's law. Using symbols, we write Ohm's law like this: V is proportional to I, voltage is directly proportional to current. When one quantity varies directly with the other, the ratio is constant. Ratio remains same. That is, the ratio of voltage to current is same, and that constant is represented by the symbol R and is known as resistance of the conductor. Today we are going to discuss about resistance. Let us understand what is resistance of a conductor. Students, you know that the flow of electrons through a conductor constitutes electric current. Potential difference is the necessary condition. Once the potential difference is maintained, electrons flow through the conductor. However, the electrons cannot move freely, easily, because the conductor is not hollow. It is densely packed by atoms. And atoms are in the state of vibration also. These electrons have to move among the atoms. What happens when the electrons start moving? The atoms attract the electrons. This attraction limits the flow of the electrons. That obstruct, that attraction between the atoms and the electron obstruct the flow of the electrons. That means electrons need to struggle to pass through the conductor. They have to overcome the force of attraction for their movement. So we can say there will be some obstruction or opposition to the flow of charges, and this obstruction is what is called as resistance of the conductor, of the material. So what is meant by resistance of a material? The property of the material or conductor to resist the flow of charges. The property of the conductor to obstruct the flow of charges is called resistance of that conductor at that temperature. Students, let us consider one example. Here is a simple circuit. Here is a dry cell, and that is a voltage source. Charges flow from voltage source to conducting material like copper, aluminum, then to switch to bulb to conducting material. Once again it returns to the dry cell or the voltage source. The charges even flow through the voltage source also. Wherever the charges flow, they face some level of obstruction, but the degree of obstruction varies from material to material. See, I have listed out some 4 materials, broadly classified the materials into 4. Some materials have low resistance, means obstruction is less. The charges can flow easily. They are called good conductors. Materials with low resistance are termed as good conductors. The charges can flow easily. Obstruction is less, flow is, charges can move easily because obstruction is less. A material with appreciable resistance, here it is low, it is appreciable resistance, having some level of resistance, and they are called resistors. So resistor is a material having appreciable resistance. So it is represented by this symbol. The symbol itself gives you the idea the motion of electrons is not so easy. It is which one? The electrons find difficulty in moving because it is similar to road humps along the roads, and these road humps slow down the movement of vehicles. Material with even higher resistance, they are poor conductors, and if it is infinitely high, they are insulators. They do not allow the charges to flow. Here they allow the charges but not so easily. So we can conclude that this property to obstruct the flow of charges, that is the resistance of a material, depends on its nature. Some substances offer higher resistance, some substances offer low resistance, some substances have moderate resistance. Based on that, we have classified the materials into good conductors, resistors, poor conductors, and insulators. So resistance depends on nature. What are the other factors on which resistance depends? They are length, thickness, and temperature. Let me consider this example. In example 1, I have two materials. One is A and another one is B. They are different materials. They are of same material. For example, copper. This is also copper. This is also copper. They are maintained at same temperature, same thickness. The area of cross section is same, and they are of same material. Same material, maintained at same temperature and same thickness. Only thing is, I have varied the length. Dear students, you only can say in which material electrons have to struggle more. In which one? In which case? In B. Because the length is more. So electrons have to cover longer distance. Obviously, resistance will be more. Obstruction will be more. So we can conclude by saying resistance of a conductor is directly proportional to length. As the length increases, resistance also increases. As the length decreases, resistance also decreases. This is a second example for direct proportion. Already we have discussed one direct proportion. Voltage is directly proportional to current. Your resistance is directly proportional to length of the conductor. Here one more example. Same material, once again, here same length is same, temperature is same. The factor which is very over here is thickness. Students, you only can say, here also you can say, in which material electrons can flow easily. In B, the electrons can flow easily because the available space is more. Electrons move easily through B. So we can conclude that resistance of a conductor is inversely proportional to its area of cross section or thickness. More the area, lesser the resistance. More the area, lesser the resistance. Electrons find more space and they can move easily. If area is less, resistance will be more. If area is less, electrons cannot move easily in the smaller area. So resistance is directly proportional to length and inversely proportional to area of cross section. I have combined these two relations. Resistance offered by a conductor is directly proportional to length and inversely proportional to area of cross section. So once the proportional constant is written, R is equal to rho into L by A, where rho is called resistivity of the material. What is meant by resistivity of the material? Once again, resistivity is same as resistance only. So resistivity of a material is the resistance offered by a conductor of unit length and unit area of cross section when the electrons are flowing perpendicular to the surface. I repeat the same once again. Resistivity of a material, which is represented by the symbol rho. Resistivity of a material is resistance of the conductor of unit length and unit area of cross section when the electrons are moving perpendicular to the surface. Here I have taken cubes of length 1 centimeter. So the resistivity helps us to select the material for the practical purposes. Students, one thing you should understand. Now we have two tools with us to control the flow. One is voltage, the other one is resistance. Resist is which one? We control the current by varying the voltage. More voltage, less current, less voltage, more voltage, more current, less voltage, less current. Another thing which controls the flow is resistance. More the resistance, lesser the flow. Lesser the resistance, more will be the flow. So we can control the current either by varying the voltage or by varying the resistance. Thank you children. Have a nice day.